anomalous or is not as what the others are. So to summarize, there are many techniques which are listed on the left-hand side, and just to claim that they are not exhaustive, there are many more techniques. Some of them we have learned just now. So there is something called binary classification that we saw. Then there is multi-class classification, where the classes are not just two, like in our example we had just two, male and female. Clustering, where we want to group items or data sets based on similarity between them. We'll see a detailed example of these in my use cases further. Anomaly detection, and many others like regression, ranking, frequent pattern mining, and many others. Similarly, on the right-hand side, we've got some tools, which are things like Apache Hadoop, Giraffe, Mahout, Weka, POS-Tagger, which is part of SpeechTagger, PortalStemmer, and many such things. So let's look at an example. We've seen some techniques, what enables big data analytics. Let us now look at some examples of how this gets realized. So let us say we have got a lot of tweets. I assume that all the audiences are already familiar with what is called Twitter, and where a lot of tweets happen short text messages. And the objective is that we want to categorize them, that they are either giving a positive opinion about the object being discussed, or a negative opinion, which could be a political party, or it could be a new mobile phone being launched in the market. But the challenge is the rate at which these tweets arrive is really very high. So how do we do? What do we do in this case? So we often model this problem, for example, using classification. We do the feature extraction, like we talked about earlier, the color, shape, etc. What kind of features would work in this case? Let's take a quick look, and then we delve into what is called the use cases for something. So here are some features that we can extract. And those can be as simple as words. Those can be n-gram or unigram. There can be some words which indicate time. There can be some words which indicate URL. We can use number buckets, because people often tend to use numbers, 1 million, 10,000, and things like that. And we can have numbers and discretize these features based on these buckets. People use emotions, smileys, etc. We can use those. We can extract them, and then build some kind of probabilistic model which says that what is the probability of this tweet being positive if such a feature is used or such a feature is not used, using something called classification, which we learned in some of previous starters. And then there are some more features which are listed here. There are some mathematical terms we can just ignore. And believe me, this is just the last chart of my tutorial. And we can then quickly go into use cases. But then this helps us classify these tweets that we get. For example, either in the positive category or a negative category. So now we've seen a quick tutorial. I think I was very quick in giving this tutorial because I wanted to spend more time on the use cases. And here is my first use case. But before I proceed further with my use cases, let me draw your attention towards the bottom of this screen, where I have listed some text, which is actually a pointer to some of my publications or our publications from our group at TCS. And these publications will point you to the exact documentation on the web as to how exactly these use cases can be realized in terms of core algorithmic details of which I cannot talk about in such details in this session today. Okay, so coming back to our first use case, imagine a situation that we witness some natural calamity. For example, earthquake or tsunami. Events of this nature attract global attention. They appear almost in every newspaper in every country. And but however, there are some small events, small-time events, such as fire in a factory, which don't sometimes even make it to the national news, forget about international news. And it is observed that the cumulative losses because of these small-time events is also significantly high because they silently disrupt the supply chains today. We have globally distributed manufacturing process or supply chain process. How does it affect? According to a survey which was conducted back there in 2011, it was observed that 85% of 550 companies observed that they witnessed at least one supply chain disruption in last 12 months. So that's the extent by which today's supply chains are getting suffered because of such accidental events, such as fire in a factory or labor strike. So how do we solve